So, you ever wonder how we really know things about the human mind? I mean, it's not just magic, and it's definitely not just someone's opinion. There's a whole process. Today, we're going to open up the investigator's toolkit and see how psychologists go from a simple question to a real, evidence-based answer.
Here's a question I bet you've heard a million times. Maybe you've even worried about it yourself. But how would we find a real scientific answer? This is exactly the kind of puzzle we're going to tackle, and we'll use it to explore every tool in the psychologist's kit.
You see, to get a real answer, we have to move beyond just guessing. We need research. And all that really means is a systematic investigation to find answers to a problem. The key word there is systematic. It's not random, it's a careful, structured process designed to find the truth, not just confirm what we already think we know.
Okay, so where does this systematic investigation begin? Well, the very first tool we pull out of our kit is the hypothesis. This is where we make our educated and, more importantly, our testable guess. A hypothesis isn't just some random thought. No, it's a super precise, measurable prediction. It's a formal statement about a potential relationship between two or more variables. So for our question, our variables are pretty clear: screen time and sleep quality. Our hypothesis has to state exactly what we think is going on between them.
Now, here's a part of the process that might seem a little backwards at first, but it's absolutely crucial. Researchers actually start with something called the null hypothesis. This is the default, kind of skeptical view. It basically assumes there's no relationship at all. In our case, that screen time and sleep have nothing to do with each other. Then you have the alternative hypothesis. This is what the researcher actually thinks is true, that screen time does affect sleep. The whole goal of the study is to gather enough evidence to prove the no-effect idea is wrong, which then gives support to their real prediction.
We've got our testable guess, but what exactly are we measuring? I mean, what do screen time and sleep quality actually mean in a study? That brings us to our next tool, defining our variables. This is all about getting crystal clear on what we're looking at. First up is the independent variable. The easiest way to think about this is as the cause. It's the one thing the researcher is actively changing or manipulating to see what happens. For our study, the independent variable would be the amount of screen time we ask people to get right before bed. And if the independent variable is the cause, well, the dependent variable is the effect. It's the outcome we measure to see if our change actually did anything. You could say it depends on the independent one. So here, we'd be observing and recording the quality of each person's sleep.
But hold on a second. What about things like coffee or a really stressful day at work? Couldn't those mess with your sleep too? Oh, absolutely. In research, these are called extraneous variables, stuff on the outside that could muddy the waters. A good study has to account for these and control them to make sure we're really just measuring the effect of screen time and nothing else. Okay, so we've got our hypothesis and we've defined our variables. We know what we're testing. But who are we going to test it on? This brings us to the next vital tool in our kit, sampling.
I mean, it's obviously impossible to include every single person in the world in our study, right? So how on earth do we choose a smaller group that can give us results that actually mean something for everyone else? That's the big question of sampling.
And the solution is to study a sample. It's just what it sounds like, a smaller representative of a large whole. Think of it like a slice of a much bigger cake. The really important part is that the slice has to accurately reflect the entire cake. If it doesn't, then whatever we find out from that slice won't tell us much about the whole thing.
So, there are two main ways to pick that slice. The gold standard is what we call probability sampling. This is where every single person in the bigger group has an equal, random chance of being chosen, kind of like pulling names out of a giant hat. This gives you the best shot at getting a truly representative group. The other method is non-probability sampling. This is less random and is often based on what's easier convenient, like say, just studying the students in your own class. It's way easier to do, but it runs the risk of not really representing the whole population.
Okay, we know what we're testing, what we're measuring, and who we're studying. We are almost ready to go. But before we collect a single piece of data, we have to talk about maybe the most important part of the whole process, the rules of the game. And that means facing potential bias head-on and following a strict code of ethics.
Bias is this sneaky thing that can totally ruin a study. It can be personal bias, where our own beliefs just cloud our judgment. It could be observer bias, where we only see what our background has trained us to see. Or it could even be expectancy bias, where we just want a certain result so badly that we unintentionally start to find it. A good scientist has to be on guard for all of these things to keep the research objective.
But beyond just avoiding bias, great research is really built on a foundation of integrity. It's about, as this quote says, keeping your promises, acting with sincerity, and striving for consistency. At the end of the day, it's all about building trust with the people in your study, with other scientists, and with all of us.
And that trust is earned through a really clear ethical process. Before a study even starts, people have to give their informed consent, which means they know exactly what they're signing up for. During the study, researchers have a duty to minimize any potential harm. And afterward, there's a debriefing where the full purpose of the research is explained. It's all about respecting the people who make this science possible.
So, a hypothesis, variables, sampling, ethics. We've walked through a lot of tools. You might be wondering, why go through all this trouble? Why does this super rigorous process matter so much?
Well, here's the big takeaway. This whole toolkit, this entire systematic process, is what elevates our understanding. It's the system that lets us move past saying I think or I heard somewhere and allows us to say the evidence shows. This process is what makes psychology a science, and it gives us reliable insights into why we do the things we do.
So to wrap it all up, the investigator's toolkit is really built on 4 main pillars. First, you start with a testable guess, your hypothesis. Second, you clearly define what you're going to measure, your variables. Third, you carefully select who you're going to study, your sample. And finally, you always follow the rules of fairness and accuracy. That's your ethics and bias control.
So, there you have it, the basic tools. Hopefully you can see the world a little differently now. Not just as a series of things that happen, but as a series of questions that we can actually investigate. So, I'll leave you with this. Now that you have the toolkit, what common belief or piece of advice about human behavior would you want to put to the test first?